Hello. It is time. There's an update to Godot, but I think I'm not going to update my engine version yet. Unfortunately, Steam always forces me to, even though I set specifically like, hey, I only want to use this version. It's like, oh, okay, we're gonna update anyway. It's got to be some glitch, because you gotta either pick between latest or the specific version that also happens to be latest, and I think it just checks to see if it's the same version, and if it is, then it will require an update to launch. Dumb. Dumb. Also, I looked at this game that is their featured game for this update. They need to consider some things about how they pick which games are going to show up on their featured list, or featured in their updates, because this is not a good look. Definitely, I don't want to look at a game engine and say, oh, here's a featured game, and look at it and be like, dude, what is that? Why is that the featured game? Essentially, this is like it's an odd game. It's a mechanic smash, and I was looking at the gameplay for it, and it's too slow. It's really odd. And supposedly, the gameplay being good at Tetris is not good for the game. For your enjoyment, I guess. If you're good at Tetris, this game is not going to be fun for you. It's gonna be working against you if you're good at Tetris, which is really silly. Yeah, it's slow. It's a mechanic smash, and I mean, you can look at it. It's Balatro with Tetris, and it's supposedly done poorly. I mean, I could just see it too. Just looking at the gameplay and looking at the screenshots, it doesn't look good. It looks like it is a demo that you find on... It's like a demo for someone's first game, is the idea. Like, you've made some games, you're making demos, and this is like your first real attempt at making a complex game, and it should just stay as that, an attempt. They should not put this front page on their update. Godot should not be putting this up. Anyway, I'm just going to look through this. See whatever... Well, I won't be seeing any breaking changes they decided to put in this one, because they don't like to document those sometimes, just on vibes or something. I don't consider this a breaking change, even though it changes the API and breaks valid usage of the API. Not a breaking change. You know, it is a breaking API change. A breaking API change is adding a new optional parameter at the end of a function that nobody has ever used before. That's a breaking API change that needs to be documented. Guard against non-main thread emission of editor file system change signal. You know what, if they just had... I feel like this shouldn't be a guard. This should just be how it works. Non-main thread emission. I assume what that means is you listen to the signal and then it complains to you that you're not on the main thread. Or something like that. Or worse than that, you don't even get the signal. Initted. Is it seriously called initted? and knitted. Nothing. No known incompatibility. Oh, but if you mention it, we're going to tell you no, it's not an incompatibility. Because we decided it wasn't. And we gotta retroactively justify that bad decision. Okay. But Steam did force me to update it, so I have to make it go back. I can just do L. Unknown argument L. It's S. Why do you have to do S and... no. No. N. There. Oh, I get it. It's because they don't differentiate between patch versions. So when I select 4.7, I'm actually selecting the latest 4.7 version. That's how that works. It's a bit annoying. They only do, like, maybe 2 patches per version. Which honestly I think is not enough. They should have way more patches per version. They should, like, seriously focus on stability and bug fixes. Because there are still a lot of bugs. There are bugs from, like, version 3 that still haven't been fixed. Alright, so I want to write... I need to have a debug tool for... for visualizing input data. Just of any kind, I guess. So... debug draw, I think, is just... I don't know. It's like for shapes so far. And I have no clue how I could expand it to draw. Yeah, it's for drawing 3-dimensional things in the world. Things in 3D space. It's not for 2D. It's really not. Essentially, I don't want to print out, like, numbers to the console and then, like, try to interpret those. I want to have a visual graph on the screen that is updating. So I can see very clearly anything strange that's happening. And then... wrong one. I probably need to look at comprehending this completely. They have this... I mean, this chart just sucks. And maybe just look it up. Because like I said, it seems definitely incorrect that when you're below your target, you quickly reach your target, and um when you're above your target, you weirdly sit like double the error above it, or half the error, whatever, however you would say that, above it, and then you very slowly come down into it. It doesn't seem correct. It seems like it must be a mistake. I mean, actually, I can kind of understand this one. These are the constants. So add the constant proportional and derivative, multiply that by the error. I assume E of n is the error. It must be the error, right? Why don't they define the error function? Plus, to n summate. Okay, so this is just all of the errors that you've accumulated so far. J, error J, I guess. The sum of all the errors multiplied by that, subtract the derivative multiplied by the previous error. I can just immediately say that's definitely not even close to what this was doing. Yet this is a lot different. Huh? That's not the algorithm. That's not what this is. Huh? Also, wait a second. What is this, by the way? They do this. This line and this line are identical, except they've changed the n to j for a j to n. What? they break it apart and then they rearrange it back. It's the same line though. All right, you know what? I'm just going to say whatever this is, it's garbage. This is probably just garbage. I don't understand why they just did extra steps here just to change the end, just to flip around the J in the end on the summation. And this one isn't even correct either because this is N to J, but your unit thing is N, so it should be N in here. What am I missing? Because this is just a different algorithm. And then they do this part. We can construct the algorithm's block diagram. Where does the 1 over z come from? I guess they say that 1 over z is the error. Yeah, I don't understand what 1 over z is there for. The other thing is they have a 2, the number 2. I see that appear in one place, and it's right here. I guess 2 places. 2 times the previous error. A1. Negative kp minus 2 times kd over dt. Like, why? Why do they do this? And not this one, which is obviously the meaning of their... This is the final equation. Oh, here's our block diagram. Oh, here's what happened when we ran that. But also I see the same issue. This diagram is impossible to see, but it looks like it sweeps over it and then it takes a very, very, very long time to come back into it. So it seems like it's still, it feels like a mistake. I can't believe this is correct. So, all right, how about this? How about this? How about forget all of that? How about literally, I'm not going to do that anymore. And I'm not even going to worry about trying to make a simulation. Or a visual model. It's just wrong. I think it is just incorrect. This one, it seems, no. This one seems like the most reasonable thing. The current error. The current error accumulator. And then the derivative. Though I feel like maybe derivative could be improved with multiple samples. Instead of only the previous sample. Okay, I'm just dropping it. I'm not doing any of the infinite impulse response at all. It's just this. Yeah. Should I clear that one too? Well, I mean, this prevents it from doing it anyway. So there's actually no reason. there was a different thing somewhere. Where is it? But it had a lot of parameters. It just seemed like too many. We should just look it up and find something. Because I think Wikipedia might be wrong about this. Well, okay. Well, I mean, the basic one, the diagram, is kind of impossible to misinterpret. Okay, never mind it. The derivative is already immediately wrong. Wait, what? Wait. This is the measure value. Okay, right. I was going to say, what is this? But then a sum. We're adding that. Well, okay, no, I'm just confused by that thing. Show me this. Derivative times the error over delta time, which is different because that's not this. This is subtracting. They're just saying multiplied by the error, divide by delta. Yeah. No. You're wrong already. You're not following that. That's not what the diagram says. This is the constant. No. Never mind. I understand how this works. I was reading dt as delta time. This is the derivative of the error to time. Which that is what it should be. Okay. And if like you just need more derivative gain, because that is what should stop this from happening. Okay. There's one thing that I don't know. Should I try it? Where is it? There is... I had it. I had something. Was it not mentioned here? Maybe it's here. It's not this. But maybe it's mentioned. It was this one. Wasn't it here? Where was it? Here? Don't I have it? I think I have it. I think I downloaded this. There we go. I did have it downloaded. And it was probably the same one. Yeah, probably the same one. Alright. essentially it was this term here. There's just kind of the extra bit at the front. And then I think, because other than that, it's still just normal proportional integral derivative. A very big part of this was that, look, no overshoot and super fast response time. Really fast response and no overshoot. Or if there was overshoot, it's really small. Like we're in ones away from the target, right? As like a ratio of it, you're like less than 1% off. You know, you're fluctuating within 1% of the target. Instead of in my case, which I'm fluctuating from like 100% of the target. Immediately. Okay, now I just remember like where the important bit was, because they just have the diagram. Some of this was just explanation. I think this is the full algorithm, right? Right. They have this B0 term. Which requires that you have an initial estimation for this value. What did they decide it was? This is after they picked. They selected it as 104. And then they use a different setup for some reason. They go through this, okay, they use this setup. They go through this whole thing of like, oh, here's our new block diagram, and then they just change it to something different for their test. So I mean, okay. I feel like I shouldn't really need it. But the fact that it doesn't overshoot and it's actually really fast is super nice. Hey, Deadon. Posted a 225 gigabyte lossless video on YouTube. It took it 6 hours to prepare. Why'd you do that? Why would you do that? Derivatives. Derivative is the change of something. If I have an angle, if I have a plot, if I have a function showing the angle of something over time, taking the derivative is the velocity. I want our video to look good in not even 2 hours. You realize YouTube just crushes it anyway? They do a lot to make sure that the visual quality is barely affected, but they do crush it. So, I don't know. I feel like you might have gone over past the point of diminishing returns there. Yeah, okay. If I have a good system, this should be good enough. And yet again, the 700 line, 600 line update function, of course. Godot is just so sure about that. Why don't they use the exact same tree parser that or whatever custom language? Custom language. I got it. I'm already upset. I'm just already upset. Change. I need to change. Some settings. Sure, I'll use 5. It looks like everything just updated. Well enough. It's a little loud. Okay, what do I have? I think I have a breakpoint. I probably am not trying to mark this one. Oy. Well, no, I think I am. Okay. guess I'm just going to walk through this and check. So first thing we do is we apply everything to say, all right, here's the prediction. Right. This is should be going in reverse. So this is the tarsus and tibia. So I'd be looking at the x angular velocity. So they're roughly the same. And then they nearly equalize, as is part of the prediction. So the tibia and femur. So I'd be looking at the y. No, this one is still only the x, so I'd still be looking for the x1 to equalize. By primarily a change to the femur, I think. So I should see body velocity 0 change. Yep. Tibia, that game was fun. What? Alright, so now I'm looking at the y of these two equalize, primarily with a change to number 1. Yeah, okay. We just added like 2 zeros to it. Cool. So that's the prediction, and then I apply the transforms to these, and then I limit those transforms. Doesn't know? Yeah, I don't. I believe the limits are still pretty good. Yeah, I'm looking at effectively nothing happening. Many 9s. This should be nothing. Good. Oh yeah, I was here. Okay. Skip ahead. So this is much simpler now that it's just setting it to the joint velocity. So it should be 07, 007, and then barely more than 007. This is a lot more than that. But it should be okay if it's a little bit more. How did it? Integral is k, or yeah, that one plus that. Prior is 0. Error minus prior error. I guess if the prior error was 0, then yeah, that makes sense. Maybe derivative isn't supposed to be this high. I mean, it should be fine, I think, because it's going to come back and correct for this. So at least in this case, it is starting with something a little bit more than maybe it needed, but I don't know. This is... It might be too much overshoot. It's almost double what it should be. But I guess I'll find out. So I should just hit continue again. Go down here, I'll look at the estimations. So there should be some velocity now happening. Tarsus and tibia again. And now some accelerations. Hopefully these two still should be equalizing. Roughly. Okay, good. It looks like they did. Well, I guess the main thing is that every time this runs through, it's actually sort of starting over from the starting over. But with some changes to their desired velocities. And then it will rotate. So this one should be... Oh yeah, it's just always running in reverse. Yeah, I don't do any backwards check anymore. Check Discord for your cousin. What if I don't want to? What if I really, really don't want to? You do want to? I really don't. Okay, so previously I said I wanted to be at 0, 1, 1. So I want to see a negative here for sure. Good. I see a negative. 0, 0, 4. And that is a smaller that is a little bit less than half the original value. The previous one was a positive 0, 1, 1. This is a negative 0, 0, 4, 7 or 4, 8. It's definitely smaller. But what is the new desired velocity? 6, 3. 0, 0, 6, 3. And hopefully the idea is that this rotation error should approach just being the same value as IK angle, but its value is substantial. There's 3 zeros and a 2. This is 5 zeros. There's a big difference to these. But that is the goal. Those two values should be converging towards each other quickly. So I'll just take that off, hit continue, and I guess I'll look at these again. They're sort of passing each other, which is interesting, because I believe this was a 4 and a 2, and now it's a 1, 4, and a 2. One, 2, 4, 7, a 1, 4, 5. Yeah. What is it right now? 0, 0, 3. I'm about to set it to 0, 0, 1. I think it's too many iterations. Plus, this angle is just way still dramatic. It's like we're talking about cents and the error is in tens, hundreds of dollars. Kind of a thing. I think that's the comparison between these two. Or I guess it's more like saying pennies versus a dollar. Like, hey, I'm missing like 2 cents. And we're like, okay, so we're going to give you $2. It's way too much. Velocity doesn't seem right either. I would think the velocity needs to be something different as well. Wait, the joint velocity didn't change? Did I have 011 before and this is 001? Theories say Anakin and Darth Vader are brothers. I really hope that if I ever do something, two things don't happen. People don't take facts presented in the story and discard them in favor of what they would like to be true. And also that someone, if I'm unfortunate enough to have to write a story with another person, that the person doesn't go on to retroactively change canon by saying, oh yeah, this was true, even though it was never in the story and was never presented. Go full Kojima. There's just something weird that some people really like to do, and I don't like it, where they try to put romance into stories that don't have them and don't need them. And not even just putting romance in them, but also putting them into like certain types of romance that are like really odd. Particularly, I think, just to annoy the original writer. Is this increase? Wait. Current joint velocity, target. Who did this? Was it it's mostly like retroactively changing a character to be gay. Even though romance was never involved in that character, they had no partners. And a writer's just like, by the way, that character was gay this whole time, and you just never knew it. Because it was never in the story, because he wasn't gay before, but now we've changed him to be gay. Like, that kind of thing happens. Either a writer doing that, or the general audience picking that up. maybe not a general audience, but like people who are really into story are like, guys, we gotta make this one. This romance has to be present in this story that lacks romance entirely. Almost to a point of being deliberate, that no romantic writing was ever in the story. We need to load it in. And I think that's just weird. I think it's really weird to do. On both sides. It's disrespectful to the writer and it's disrespectful to the audience, to people, to make those retroactive changes like that. I don't look at the other ones. I should look at the other ones. What are the other ones doing? This one is that value, and it was that value. This one barely changed. This one slowed down slightly. So the kissless loser should not write romance. Probably. That's not my point, but also yes, probably. I think if you have not had a long-term relationship, and preferably a relationship that results in a family, I don't think you should write romance. Because you're just going to end up writing teenage fantasy is all you're going to write. And I think it's not healthy. It's not healthy for people. You could write a story about a relationship that ended. That's perfectly valid. I think definitely the worst thing you can do is to like pull from experiences of relationship that failed and then change that for your story to basically write it with all the problems and then say, oh, but it worked out. I think that's really terrible. That's a really bad thing to do. Because you essentially say, I didn't do anything wrong, the other person didn't do anything wrong, or like this was the wrong thing that they did, and in my story, that's not going to happen. Okay, these values are decreasing. Which is good. But they are flipping dramatically. So I don't know which. It's hard to tell. This error, I think, still increases actually every time I run. The error just increases. And it doesn't correct. So it seems like there's not a significant enough response because this is a target angle and this rotation error just continues to climb. Or to get further away. But, I mean, I guess it is getting there. That's the target, and the real velocity was just slightly off from that. So it is getting close. 3 zeros and an 8. What? This is just like overcorrection. 3 zeros and an 8. 3 zeros and an 8. Wait, what? Target velocity is that value now? Okay. Mike in the main character will be a young adult and his partner will be a big muscular woman that loves him a lot. It's totally not fetish bait. My concern is mostly with teaching people that certain behaviors are fine and desirable in a romantic relationship. That's my issue. Some people are terrible people and they write very popular romance novels, and that's not good for people. Because they read that and they say, oh, that's what I should be doing. That's how this works. This one has like the same error. 3 zeros and a 2. It's probably the same thing. It wants to be slightly... well, actually, hang on. This one is actually sort of approaching what it wants to be at. I don't really look at this one, I think. Zero zero 1 5. This one's actually getting really close to it. So this should be barely positive. Or, I mean, barely negative. 0013 to 0015 is 0002. So that's actually a good change. Okay, so it seems like this one is kind of working out well. Mainly because it's not super affected by the other ones. You know what it might be? It might sort of be that... Well, I don't know. I mean, okay. This is correct in the sense that I'm simulating it ahead of time using the exact same thing that the physics server is going to do. And then I try to pick out velocities that are going to minimize all the problems. For the tibia, this seems to be doing well. I haven't really looked at the femur at all, so I need to look at the femur probably. The Tarsus, though, is not minimizing its errors at all. Its errors are just kind of like staying close to where they started at, but they're not really decreasing. Which I don't think is a torque problem. It could be a torque problem. It actually could be a torque problem. Let's see the femur. This one should have like the least work to be doing the whole time. Desired motor velocity, joint velocity. So it looks like it's getting close to it. Is it getting closer? Oh wow, it's like actually spot on. 4026. 4026. So this one has actually reached its target. But what is the angle? That's too many zeros to even look at. 1, 2, 3, 4, 5 zeros in a 4. That's 7 zeros. So it's not really, I would say this is not actually correcting that, but it is reaching the velocity that it wants to have. It seems like it's basically out there. Though this one technically doesn't have any feedback happening to it, so it should be able to hit there. Should be able to get there without much of an issue. You have to watch Lost. I know I do. Okay, so supposedly we want to increase by 5 zeros and a 3. Is that acceleration positive? 5 zeros and a 3. Okay, it's 5 zeros and a 5. Sure. Yeah, okay. Four zeros and a 4 versus 5 zeros and a 5. 4 zeros, 2, 1, 3. 4 zeros, 2, 6, 3. Okay, so they converge. They definitely, this is still the first frame, so maybe some overshoot is acceptable, because it technically hasn't had any time to set up the integral, and the derivative is also non-existent as well. Maybe it would be smart for the derivative to just do nothing on the first run, like load in. If it's a memory reset, we set the derivative to 0 because there's no prior value. It's probably fine to not mess with it. This is the femur just like that? Yep. Okay. Zero 4 3 0 1 8 0 1 3 0 2, so they do flip. 24013. Yeah. I keep thinking about, oh, what if I flip the iterations? But because I know exactly how the joints are going to run in the actual simulation, doing that, while it would give me like better values in like the real world, or might help me converge faster in the real world, it does not help me in this simulation because there's limitations to it. Okay. Desired velocity is 0075. Current velocity is 0008. And I've calculated that to be, really? That's the desired motor velocity? Is 0075? It's just so far off. Well, okay. I mean, it's not the fact that those should be converging. It's actually more the fact that I look at the angle and the rotation that I want to be at, and then I use that to compute the actual target velocity. So it sort of changes. Every time I step through it, it's really just working on a smaller and smaller piece of the problem. This does feel like a dramatic change, though. That's almost like it's closer to like a 10th than anything else. Still have a problem with the angle. Text to VRMA. What is that? What does that even mean? I don't know what VRMA is. Is this an AI model generator? I don't know any of this. Text to animation. Yeah, okay. I think people don't understand how easy animation really is. I feel like there's in the sense of like art, you know, you can say, okay, well, like picking poses might be difficult, or planning out a scene is difficult and like creatively difficult. But if you're just like, I want to blink, I want an arm raise, that's not difficult. You can do it. Uses Python. There was no JS. It seems like it uses JavaScript. That'd be weird if it's like, hey, get Node.js and then you also need Python. My bad. Okay. I mean, this seems, honestly, like it does seem pretty good. It does seem like it's definitely doing a good job at getting users JavaScript. Yeah. I love JavaScript, man. I want to write more JavaScript. I really, really want to. Dude, if Godot used JavaScript, I think it would actually multiply my enjoyment of it by 10 times. Whoops, I didn't mean to step with that. Oh well. I think it would actually multiply my enjoyment of it. Not like 50%, 80%, 90%, like 300, 400, 500%. I would be so much happier. I want to check this. Because at the same time, these, what is it? I guess the integral, right? This part should be dropping to 0 as much as possible. And they are getting really small. If Godot had a JavaScript interpreter, I would jump off a bridge. It would. The thing is, the issue with Godot, and like, I think this might just be sort of like a ball and chain strung onto the engine that it may never be able to get rid of, is GDScript. I think the fact that they have this custom script language is a significant problem. They need to get away from it. They need to just use Python normally as it is, especially for the import stuff. The fact that you have to write this, and honestly, this isn't even much of a problem either, I think, because it is, I will say, it is a little bit annoying in Python that to write classes, you need the extra layer of indentation across basically the entire file. I think this is nice that you can strip off a level of indentation by having some like syntax sugar at the top of the file, just to avoid that. But you can just use other languages with Godot. You can use C++ or C#. C++, dreadful. C#, slightly less dreadful, but still dreadful. The problem with using C++ is that you have to deal with the engine, with the code base, that really bad, no good code base. C#, I don't even know, but I'm sure it's probably a little bit nicer because there's probably just C# probably just has a better import system. I think it's just more like Java, so it's a lot nicer of an import system. And then GDScript, there is no import system. Everything is top level all the time. Which is just a crazy, huge mistake. If they just used plain Python, I can write import. So I can decide exactly what I want. If it was JavaScript, same thing. I write import. I pick exactly what I want. I would rather have 20 imports than a single time where I'm like, oh, I can't use this name because this name is just too conflicting and or too big. Well, that's the other thing. You have to use incredibly long names. You have to be hyper specific. If I am writing something to be like potentially an add-on other people can use, I have to write this garbage. I have to write 3D, I have to write physical, bone chain. Like I could just write chain. This class could just be called chain or bone chain. And that's all it would be called. And I don't have to worry about name conflicts. Because I'd be using a mature language that has gotten past that hurdle where you can actually import something. Zeros and a 2. Four zeros, 2, 1. I mean, it's basically reaching it every time. I mean, this one should be able to because it doesn't have any feedback. Which also means this one's angle should definitely be approaching. Five zeros and a 4. Okay, so this one actually seems like it kind of undid everything. It did. Whoops, I clicked right over that. What? That was all 5? Man. Okay. Well, I guess I get to see what happens on the next run then. I feel like it just didn't quite work out there. These are like the same values I saw last time. It's like nothing changed. Really? Those were just the same values I saw last time. I'm looking at the X. This one changed a bit. This one is still a very high value. I estimated it would change quite a bit, and it did not change. Mm. Wow, that amplified a lot. So I wanted to be at 0078. I actually ended up at 0036, which, I mean, that's okay. One frame, that's fine, I think. But the rotation error has multiplied by 50, essentially. Well, no, not 50. No, the rotation error multiplied by 5. From like 3 zeros and a 2 to 2 zeros and a 1. So let's see what we think now. So angle controller should have memory of the previous issues. Angle and target angle. I mean, the only issue with this one is that if I'm not predicting it correctly and I'm not getting close, the controller can only really work on the simulated values, the simulated errors. So my simulated error can be like, oh yeah, I'm going to be super close here. But then the real error comes in and it's dramatically different. It's still possible this could be a torque issue. Yeah, it's more that this error up here wasn't really corrected. And what I actually correct for is I actually correct for... I'm technically working to approach the velocity that I want to be at, not necessarily approaching no angle error. Actually, wait. The IK angle. I think it definitely increased. But I guess I'm not sure. So it should be like a -2. Okay, it's actually like a full negative. Gonna lay down. I'm so tired. All right. I hope you're not getting what I was having for a while. Right, for a negative angle, it should be a positive. I mean, this is correct, but it didn't work. It didn't work. I was standing up for over 12 hours editing a video yesterday. Sleep at 2 a.m. Dude. Well, yeah. That's reasonable tired then. That's reasonable. It might be a torque. I feel like I can say there's a torque issue. So friction 4 powered 14, friction 4 powered 8. I mean, I guess it's not gotten up to torque yet. So maybe I just continue waiting and just going through this slowly. You know what? I feel like I shouldn't be cleaning the velocities. Because I feel like when I'm doing that, that's an issue. Because I'm technically losing the information that the tarsus is losing the information that the tibia is moving. So it kind of can't really do anything. It can't actually get to do what it's trying to do. Because every time it's just like, oh yeah, I move here and the tarsus tibia moves there and we're good. And tibia's like, oh, I move up here. And the tarsus never gets that information back. Because it's always like, oh yeah, we do this and then this happens. Do this and then this happens, right? So I'm actually dropping that information. So, the resetting though, I think was necessary because of even, well, okay, I should probably, okay, I think I should figure out how to make it so I can retain this information every time. The difference being that, because it is kind of wasting information, right? If I keep working on the same value, or if I'm iterating through it every time, then I'm actually getting all that feedback to happen pretty quickly. So there's an issue with a certain I think there's an issue with a certain amount of buildup that happens where we're translating too much. I think it's sort of in this stage. Because of this. It's kind of this. This part makes it a problem. Because it is that you're supposed to get all the velocities set. You apply it one time to position and then you do all your position constraints. So how can I make it so that I'm doing this one time, but I'm also still building up the position constraint corrections? Yeah, this is basically the line. These are lines. What's more like this one? This is the line that is forcing me to reset the velocity and reset position because I have to do velocity and then position. How can I make it so I can continuously update this and iterate it? I mean, I suppose since I'm doing it this way, then it's fine. If I don't do it that way, then I will have to come in here and bring that bomb guard stabilization factor back into this. I think it just may not be possible, and that's why you just do velocity and then you do all your velocity, one position step all your position correction. I wonder if I could just do it like where I say, all right, let's rotate 20% and let's correct 20%. And then I just do that every time. But I think that probably doesn't work in the way I'm thinking it might work. It probably doesn't work. All right, I think I've got it. Since I am only moving the bodies and I know which part they are, I can just access that transform and just start with that transform every time. So I can just say, part initial basis, or I'll just say this will stay body state transform, and then basis will be index. So I always just start with the initial value and I rotate it according to the velocity that I calculated. So now the velocities can move all together, and then I would just do a single position step. They should only be rotating because I only change the basis. I don't actually do any translation. So that should all still be fine. Then I come down here and I say, well, I'm starting from the initial, and then I do the initial, I rotate it by the velocity that I calculated, the working velocity, which I think I should just leave and not correct every time. I should actually like do velocity. Yeah, because I say false and then true at the end. I mean, technically I don't even need to do that because because of the order that I'm going in, and that I'm always doing just that transform on its own. Oh, well, I guess not, because then the parent transform will reset. Oh, wow. You know what I'm kind of doing wrong? I need to be moving everything, and then I update the constraints. Yeah, that's really stupid of me. I need to move everything and then update constraints. Technically, I can apply the velocity here and then move it as well, because I know that this one's velocity is not going to change on the next call because of the way that it's moving up. Okay, so I can actually do just these here. And then I guess I just have transforms here. Which, because of how it's written, I'll just write this out. Okay. That should be a lot better. This should really allow it to get those correct. And now it's kind of the case where I don't actually want to do this. Yeah, I actually don't want to do this at all because I am setting every transform. The one transform that I do need to reset, though, is definitely the main body. I need to reset that one, otherwise I'm just going to keep moving it. But these ones reset because I always draw from here, and I rotate that based on the calculated velocity. And yeah, I shouldn't need to do this one, because if I do it at the end, then it's always going to be done. So I only have to reset the velocity at the end here. Though I do wonder if I should fix the main body velocity. Because, I mean, what's going to happen is it's basically going to cycle through. Right now I have it locked on the y-axis, so it's never going to rotate that way. But what's going to happen is as it goes through, this joint's going to run, it's going to move that one slightly, and this joint's going to run, it's going to move it slightly, or it's going to work on that slight change. But, I mean, I guess that's close enough to what really happens. The real simulation will do all the tarsus, then all the beam joints, then all the tibia and all the beam joints, and then all the femurs. This one I do the full leg at a time. And I'm also skipping the beam joints. Do I need to reset the velocity for each solution? Maybe I shouldn't. Because if I don't, then that means I will accumulate all those small changes, and it's technically in the same order that it's going to run in the real simulation. So it should tend to make it, it should just help it be a little bit more accurate. Okay. Oh, okay. I do see it now. The issue that I'm getting is that it technically, this would have to track that accumulated lambda and make sure it doesn't actually exceed the torque. Because otherwise it will it'll apply the full torque, and it's going to apply the full torque again, and then again. So if it wants, so it is going to overcount. It is going to think that the thing is maybe more responsive than it's meant to be. But if I just fix that, if I can just make it so that the torque is properly limited to the max torque, which I can. The code is nearly here. I just have to somehow store that. And perhaps I can just store it here. And then I believe I can probably just copy it exactly how, let's do this. Exactly how it's implemented there, because the way that impulses work is they just keep the running number and they always track it. So just calculate lambda, new lambda. It's just limited the same way. And then I'll recalculate lambda. Okay. Now the one thing that gets me is this. That's actually always 1. I actually know for a fact that that's 1, so never mind. This is what was getting me, is maybe this happens. Which actually does mean that this happens, which means I have to do this every time. So I guess technically when I set up, I have to do that warm start. I have to apply it right away. Or I can just 0. I can also just 0 the value. That would also work. I'll do that. I'll just 0 the value. I guess I can do this, right? Technically, it is supposed to do both. Dang. Wait a second. Maybe I can run through it normally, right? And I just set part. And on the first run, I also set parent. Because I always know that parent, when this is 0, is going to be the main body. Because what I was thinking, I was thinking I shouldn't do that because of because I'll be applying it kind of the wrong way, but it actually doesn't matter which way I apply it in. What does setup here do? Okay, so this will actually calculate there, so I do have to pull it after that. All right. I shouldn't need this. Or any of that. Yeah, because I will save the part angular, and then I will update the part angular in its parent. And then in the next one, I've already saved that. The parent that I'm going to update, I've already saved its initial angular, so I'll just update it again. I'm safe to update it because I've already saved it. So now I'll be keeping my velocity changes. I will be refining more appropriately. And then the lambdas are accounted for. Should probably be like new total instead of no. Let's see that. Oh. Oops. Okay. Task. Should probably take that. Okay. Right. 040. What is this? Yep. Right. Okay. And then in theory, these should be nicer because the next time it's going to come around, it's going to say, all right, we had wait a second. I just realized there's something interesting with this because the max torque is set, but technically it doesn't apply. It doesn't really apply the max torque because you can see here, like if it was applying the actual max torque, it should have been able to like fully equate these to like several places, but they're not fully equated. Yeah, I just realized that what really happens is because of the way that it applies it, it technically applies only the set torque, but there is still a maximum that's a lot higher than that. So let's say the max torque is 12, but the torque I apply is 5. That's sort of the thing. Well, not exactly. Hang on. Let me see exactly where max torque comes from. Well, yeah, it's this, right? So it calculates this lambda, and this lambda is actually going to be less than the torque all the time, I think. So yeah, it's still going to apply the desired torque that I've set to. So if I set it to 4, it's going to apply like 3 something. Something really close to 4, but not exactly 4. And then because the other ones are moving, it's going to be able to, because these are going to be saved, it's going to be able to wrap back around and say, okay, so we got really close to what we wanted to be, but now it's wrong. Yeah, I can just rotate it right away. So let me actually step into it and look at it. So torque is 0.4, right? But the lambda that's going to calculate is not that. It's a really small value, right? So it technically does exactly what it should be doing, but not fully. Wait, this is applying backwards. Yeah, no, that's correct. This part goes backwards. The setup needs to go forwards, which is what it, all right. For some reason, I thought that this was kind of going the wrong way. It's not. It's going the right way. Kind of the thing that sucks is that the position constraints I'm not really applying correctly. Those ones are applied pretty poorly. Though I don't know. Maybe I could just scrap the position constraints completely and just run this way. Because there's sort of two things. I run the position constraint to a maximum amount, which will mean I was going to say that it should help me calculate a better rotation error, but it really doesn't. It only matters if the rotations are, if the physics server comes back and the rotations are broken. Or I mean, I don't mean broken like, probably like broken like this, right? Like this one's pointing down, this one's pointing up, and this one's obviously broken. So if you're lining them up, they would be like this, and really they should be like this. But then when I do that, I'm also not translating, I'm only rotating. But even though when I fix that, maybe I should just drop position constraint entirely. Because I can't apply an iterative correction to this. Not as a like a one shot where I do it one time for each iteration, because I'm constantly changing the velocity and I'm recomputing positions. I mean, I suppose a possibility is that I could sort of do it in the opposite way, where every time I run through here, I'm actually updating. I do it sort of in a different way. I start with the initial basis. I do a partial position correction. And then that is what I start from when I do my velocity rotations. That doesn't really make sense though, because that doesn't match how the simulation runs. The simulation runs by applying the velocities. Simulation runs by updating the velocities, applying a position change from the velocity, and then correcting the positions based on constraints. That's how it works. I'll be right back. I'm back. Position. I forgot what I was saying about this. I wonder if what I should be doing is I should be using this moment to calculate. It probably is that I should do it partially. And I should find some way to iteratively step through it. Like I said, maybe each iteration what I do is I take the initial and I apply this as a correction to that initial. But it feels it more just becomes an issue when errors are extreme, like maybe I shouldn't even think about that either. Because it is probably the case that when errors become extreme, I'm expecting the part's probably gonna break when the errors are extreme. Because I'm just thinking, like, what does happen if I'm like over rotated and I basically apply a velocity that should get me to here, and then I apply a correction that does nothing, right? Because it's more meant to be, well, I mean, I guess it's like this, and I apply a correction that gets me to here, and then I calculate what that velocity should be. Except what really happens is I correct like this, right? Like if I think about this being a tibia and this being the tarsus, I would correct like this, so they both rotate. And this one's out of place now, so this one does whatever it does. And then I'm working with like a broken angle at that point. Because then I say, oh, my rotation error is this. Is after both of them have been like maximized, maximally corrected. So now that one's still like not really right. Because what would happen is I would do like 20% and then 20% and then 20% and then 20%. Like it would jump through those angles essentially in that order. I mean, maybe that is just like doing the initial. Taking the initial and only correcting for that one. And I would just do that first. The first thing I'll do is probably estimate the position constraint to improve this initial reading. I'll just run with it like this, because the assumption is also that the positions that come in are going to be, and the angle restrictions are going to be really, really close. So doing a very sort of lazy and fast, correct everything, shouldn't really cause too much problem. It should always come in really close to the correct angles. All right. Time to step through. Also, I forgot to go into calculate part velocity. Oh, no, I wouldn't be doing anything yet. Never mind. Really? How does that work? This came back as a number a lot smaller than I think it should have been. I mean, I suppose it's probably because just the x and the z appear to cancel out. The x is a negative, I take the positive of that. And then the z is a positive, I take the negative of that. No, they don't just be two negatives that summing up. So that still should have... How did this come out to be such a small value? Alright, well... I'm not going to worry about that. It's the first frame, right? Yeah, nothing has happened yet. I end up with that very large rotation error angle. Am I using the rotation error correctly? Well, the rotation error is supposed to be what happens. It's supposed to be what is happening due to velocity. So it's like saying the angle that I'm at is 1. That means I want that to be 0. So I need to apply a negative. And the rotation error is due to my velocity, a -1. So then I add those two together. So I say, all right, my positive here. So yeah. In a correct system, the rotation error should approach the negative of the angle, the IK angle. All right, so the first values are the same pretty much. I'll actually just look at all of them. Get an idea for it. This is a really low joint velocity. What? This should be like 006. Dot taking almost all of the x. But then it turns out to be nothing. I don't get it. How is that turning out to be such a small value? Very weird. I guess it really is just that axis being that little bit on the z, coupled with it being a lot larger than the y, just makes us say like, oh yeah, we're basically at nothing. Interesting. step forward. And I should be reusing velocity, so I should see these be close together already. And they are. Now we'll step in and see what happens. And they have inverted now. So yeah, this was a big issue with the Tarsus, is that it seemed like it wasn't really able to get to where it needs to be. It was just spending most of its effort equalizing. So it's approached that desired motor velocity actually, which is good. I think it should be approaching that value. I think I said before that it wasn't, but that was definitely incorrect. Or like it was saying that this joint velocity doesn't have to match this one, or it shouldn't be approaching that one because this is like the big value and this is like the small moment to moment value that I'm fixing for. But hopefully now I get a rotation error angle that makes more sense, because it'll be constantly updated. 0, 0, 3 zeros and a 2. 3 zeros and a 2, 1. Okay, yeah. And the idea is now that it's able to step through here again. It's gonna be like, okay, so this is what my velocity should be then. Okay. So that's a different thing that happened then. Two zeros, 1741, 2 zeros, 1741. So it basically reaches desired motor velocity immediately. But then the angle comes through, and the angle three zeros and a 2, 3 zeros and a 1. So it decreased. This should be 3 zeros and a 4. Okay. So it got closer to this value, but it's definitely still not right. Yeah, so it's reached it. Six and a 1. It's 5 and a 4. Okay. So it's getting close to it. I guess what I hope is that this rotation error's got to drop. It's got to change substantially at this point. And it's just not. It decreased, but a little bit. And it should be, ideally, it would be like, I don't know, even like halfway to an order of magnitude close. Like if it was 4 zeros and a 2. But it's still way too large. Am I doing it wrong? The IK angle is the angle that I want to be at. I might be measuring it wrong, actually. I think I'm measuring the rotation angle wrong. I think I should be measuring the rotation angle as where it is relative to its parent instead. That's actually what I should be doing. Yeah, never mind. That part's actually wrong. It should definitely be the angle between these two on that axis. No, actually, I think I'm right. I think it was actually right. Because I see what I'm doing now. I'm measuring the rotation angle as where have I rotated to after applying the change to the position. Okay, no. It definitely should be the relative to there. Never mind, it should definitely be that. Because the parent is also rotating as this runs, which means I need to be using the parent's transform. Yeah, that part's important. Parent state. No, it is, dang. Where do I measure it up here? This is what I'm looking for. Which way does this go? Is it easier to get a quaternion or easier to set? I think it's easier to set. Yeah, I mean, obviously, because it does all this scrap. It does a lot. Yeah, so preferably I want to avoid doing that. So I just need to check. It should be that the IK angle uh okay, in this case I'd be subtracting the rotation error then. Because if the IK angle is like 1, then I'm looking to achieve a rotation error that matches that value. So then in that case, it should be a subtraction. So I'll just say, I'll actually could just call this joint angle instead of rotation error. I'll leave that comment untouched. So the idea is I'm approaching the joint velocity that I want to reach, and then I'm approaching the joint angle that I want to reach. So that should be subtraction. And in fact, if I'm doing it like that, then I should just pass it in as the target angle, right? There's the target. Other way around. Angle and target angle. There. There we go. Okay. Run with that. I'll skip once. Nope, I'll skip once. Okay. Okay. Do I have an issue here? Because what should be happening at the same time is that this X rotation should be draining. So I'm at 01824. It's not draining. Because that's an issue. Because technically this should be matching really closely to the body's velocity, and it's not doing that. So does that mean that I should be, when I calculate the velocity, I should be doing the full thing? Because what I actually do is I dot with this. and then I don't. Maybe that's just part of the constraint, isn't it? Because what should be happening is that it should be um it's sort of like in here. Part of a position constraint is to also constrain the velocities together. But only the velocities on, and when I say constrain, I mean match them, right? How does it do this normally? Translation constraint part is an axis constraint part. And this has the insane velocity thing. Jeez. Templated solve velocity constraint. Templated solve velocity constraint get total lambda. R1 plus UX axis. Dot with the angular velocity. R1 plus UX axis. In R1 plus U. Rotation constraint solve velocity constraint. Swing twist solve a velocity constraint. I think it's actually what I'm looking at. Never mind. Because that's the motor. Dude. Tell me what it is. Angle constraint part. Swing limit. Angle constraint. So it's just running solve on all those. Damn. And it's passing that. Is rotation constrained? Swing twist constraint part. Calculate constraint properties. Providing. Okay. I do need to run this. definitely need to run this. Well, it's more like I have the position and then I equalize that. But then I should be saying, all right, well, if this is the rotation axis, then I need to do something with the velocities of I have to equalize the velocities of the other two at the same time. I wonder if I should just rewrite it in here. Create this swing twist constraint, the angle constraint, and just write both of them in here. I just closed it, but I need it back. Just closed it. What the hell? I mean, would it just be like saying get the angle? Oh, no, it's taking that. Yeah, okay. Never mind. It's just taking the axis and then rotating it by this quaternion. That's what this does. And I suppose it's a little more optimal in that way, since you know exactly what's happening. Or since you know that certain components of that axis are just 0. Like, you know it's a normalized vector, and you know it's a 1 and then everything else is 0. Probably. Um, Calculate constraint properties, swing 0. Constraint properties with bias 0. It's just setting the bias, right? Yeah. 0 and 0. So it ends up being 0 right there. Okay. So I'm actually really okay then. I'm actually really okay. Because when I run this, I can just... I just have this axis. This is the world space axis. So I can limit this way. This applies the torque. And then I can go on to the other two and just limit those to the maximum amount by doing exactly the same thing. So yeah, it looks like the way that it does it is it just goes, is there Y? Okay, do Y. Is there Z? Okay, do Z. Is there X? Okay, do X. The order probably matters, maybe. Possibly. So maybe I should just write the order in here like that. Yeah. I probably should match the order of it. No, actually, I don't think it matters. I actually think it doesn't matter. I think it really shouldn't matter. I'm gonna check how part bone rotation axis is calculated. Um, honestly, knowing how things are supposed to be moving, no. I need this, and then I need to be able to access each one. Do this. Bone rotation in global space. So now I can just get the axis directly. Basically copy this. And because of the way this one's set up, there actually is no limit to that one. Yeah, float max. Float max. Though it seems like there's something else. When limiting twist, if the twist half is equal to the twist, if these are equal, which means it's fully limited somehow. I know that it's going to be fully limited. These are both going to be equal to the same thing. The max angle is the min of the max of 0. The sine of zeros is 1. The sine of 0 is 0. So it should just be the max. All of it, all the time. I guess I could match how I do it up here, where I can just calculate this one time, get the inverse of it, and then I don't know. This, I understand this more. I still don't really understand how the other one works. Because it's like I have to provide the error of that. Well, the error becomes the, I don't know. These ones will just equalize the velocities. Cannot resolve build part. Stop lying. Okay. What's wrong with this? They should start relatively equal already. Actually, they're kind of not. The Z on these are, well, I mean, because of how it's doing it, the axes are not perfectly aligned to the world right now. They're actually going to be like that. But generally everything should equalize. The only difference being that the actual axis that I want to rotate on will adjust. And mostly the important thing is that this allows this velocity on the x-axis here to drain out. That's the really important step that I just added. Yeah. Because otherwise, we keep going through and it's like, the tibia is like, oh yeah, the femur's rotating like this, so I need to rotate like this. And it's not, that's not what's happening at all. That would mess it up too much. And then I compute the real rotation every time. 3 zeros and a 3. So I should see a negative velocity. And then we will accelerate. Very large acceleration. This one is really important. Yeah, because that parent velocity is basically 0, because it drained out correctly. So now this is reading a much more accurate value. Is that right? I wonder if that's right. I guess I'll find out. I mean, yeah, I should find out, because the angle should either get closer to target angle or do the opposite of that. Continue. Mhm. So are we approaching that velocity? Desired was 009. I'm about to say that we are at 013. So yeah, we definitely got closer. And then what about the angle? Has the angle improved? 3 zeros and a 17. IK angle is basically 0. It was previously 3 zeros and a 3. Now I'm about to set it to 3 zeros and a 1. Okay. So that's gotten better. But it still isn't there yet. So now apparently I want a negative velocity. And I have a very, very positive velocity. So that's kind of a little bit crazy. That is a very substantial change. It was at almost positive 0.1 and now it's at negative 0.1. Okay. Two zeros and an 8. I wanted to be at negative 0.4. I wound up at positive 2 zeros and an 8. But the joint velocity is approaching the desired, I guess. That's good at least. It has approached it. Then I see the angle goes. So the target IK angle is 3 zeros and a 4. Prior angle was 3 zeros and a 2. I'm about to set it to 3 zeros and a 4. Okay. So it is turning out correct. It's turning out right. And I just want to double check that I am always taking when I do the rotation. I always start with the initial and I rotate the initial. Yeah. I always take the initial, rotate the initial by the velocity that I calculated. The velocity that I'm expecting. And this delta is only for torque. Okay. And the other one, inverting, is weird. I guess I'll see if this one's going to invert. Negative 0.4. I mean, I guess the idea is that it's like found the velocity that it wants now, right? It's like, all right, well, we found what we wanted, so let's stop. I guess what I feel like I'm seeing is that this is going to come back and it's going to say, it's going to be like, all right, stop all the velocity that we just had. Or that possibly this is exploding. It might be. Five zeros and a 4. I know about this set at 2. 4 zeros and a 3. Last value was 4 zeros and a 3. So it kind of didn't change at all. It did achieve the desired velocity though. And I didn't mean to step over that like that. Whoops. I believe that the velocities cause an opposite angle, I think. So if I have an IK angle that's positive, I should eventually reach a motor velocity that is negative. I believe that's how it works. Let's see one more time. 0.01 to a negative 0.5, or negative 2 zeros and a 5. It does kind of feel like there's a lot of overcorrection happening. Well, actually, in this case, I didn't reach that. Never mind. In this case, I had the desired, and I didn't actually reach that. But hopefully this angle approaches that one now. Three zeros and a 3-5. It was 3 zeros and a 1. So I got further away. And this is the tarsus. Okay. What did I see the problem was? Okay. It's kind of a problem in that I think it might just be correcting too far. Like maybe let me do this. I think I'll leave the angle at the angle high and leave this being kind of low. Because I do want this to move slowly towards that target. Because otherwise it moves too far and it ends up making the problem worse and not actually having improved anything. This was the really loud one that I still haven't fixed yet. I gotta fix that. Yeah, make that 5. Integral can probably be that high. That's probably fine. Because that is a very, at such small time steps that this accumulation is always going to be pretty small. And the faster that I correct for it, the quicker it can be to respond when the error suddenly changes. Okay, let's try that way. I'll just skip over the first run. And I'll see what the results are. Cool. Okay. So it should have been a slower correction. So desired velocity was 0035. Calculated velocity is 005. Okay, so it's actually quite a bit worse. IK angle is 0. Prior joint angle was 3 zeros and a 3. Present joint angle is 2 zeros, or 3 zeros and a 2 5. But this is the tarsus. This does have to kind of work against. This does have to work with the fact that the tibia is going to be messing with it pretty much the whole time. Though I wonder why that was the desired velocity. Shouldn't it be the opposite? If that's the angle and we're going down, then the velocity should be... Am I writing the angle in the right place? Yeah, so it's a negative target velocity now. Should see a negative acceleration. That's exactly what I see. Whoops, I guess I should have looked at that first. Desired is negative, present is the same, nearly the same value, positive. This one's also being messed with by the tarsus technically, so... Three zeros and a 4, 8. Present measure is 3 zeros and a 4. Prior measure was 3 zeros and a 2, 8. So this is getting pretty close to it. So it should still be saying to accelerate a little bit. Ooh. Okay. This is where the feedback kind of gets a bit wrong. Because it technically does want to accelerate. It does want to accelerate. But what it's about to do is it's about to decelerate quite a lot. Yeah. I mean, as long as the acceleration is... This was part of it, is that I made the acceleration less reactive to it. Why does it still work, though? Because it's actually just still... What? That's weird. Right, it seems like there is a runaway happening. Because it does seem like I'm reading the opposite of these. I'm writing a desired, and that is the same as... That's an inverted sign to the actual velocity. Yeah, because what it would normally be is this would be whatever value, and this would be 0. And what would happen is it would flip it around. I would say this minus that. Instead, now it's like the other way around, where this is 0, or well, it's not 0. Um, Well, what part of this? This is, okay, this is the tibia. I might be on the inverted velocity again. Um, the angle did approach it. The angle did get there. I'll keep stepping through. I mean, the femur came through, right? The joint velocity is the desired velocity. And then let's see if the angle is right. Desired angle, 5 zeros and a 4. Previous angle, 4 zeros and a 3, 4. 4 zeros and a 3, 4. Let me see exactly what it does then. Because it's a positive rotation that I want to make. Measure, target, present velocity, measure velocity. Okay, yeah. Technically, this is supposed to provide a negative, and I mean it is providing the negative velocity. 3 and 1 6. All right. Yeah, I mean that's this should want to have a negative acceleration, and it does. Yeah, I mean, it seems right. Wind velocity desired. Okay, it's quite a bit smaller now. I just wonder if there's an inversion happening. I don't know, specifically the Tarsus is strange. So I want the angle to be basically 0. Previous angle was 3 zeros and a 249. I'm about to set it to a 290. Okay. Yeah, it got worse. Okay. There might be an issue. With the velocity, I don't know. It's hard for me to tell. The joint velocity has gotten further away from what it wants to be. What about the angle then? Target angle 3 zeros 487. Previous angle of 3 zeros 402. Current angle 3036. I guess it is the case that both these want to be a positive rotation then, right? Because when I think about the setup, but they should both, not positive, they should both want to rotate in the same direction. So the Tarsus wants to rotate up. Tibia also wants to rotate up. I meant the other way around. Tibia wants to rotate up. Tarsus also wants to rotate up. So they're both going that like counterclockwise rotation. The thing that's weird is that their joint velocities are, they seem like they're going the opposite direction. I mean, maybe it's correct. Maybe it is correct. Because this one's still approaching that desired velocity that it wants to have. And this one doesn't have any feedback happening to it. And if the angle is also still approaching, then target is 5 zeros and a 4. Previous angle was 4 zeros and a 3. Current angle is 4 zeros and a 3. Okay, so this one also seems like it's not changing, but is getting the velocity that it wants. I don't get this one. It's not changing anything. The angle is not changing. Yeah, joint velocity is still approaching the target. Desired is negative 0.004. Joint velocity is still getting closer to that. But then angle. If the angle isn't getting closer, then what does it mean? Wants to be basically at 0. It was previously 3 zeros and a 2 9. It is now going to be 3 zeros and a 3. I'm just surprised by how slow it's actually changing. Desired velocity negative 0.04. Prior velocity positive 0.02. And it's increased again. Weird. So the tarsus and the femur are reaching the velocities that they want to get to. But the tibia is like kind of going backwards. And I guess now I'll see what the angle is doing. We want the angle to be at 3 zeros and a 4.8. It was previously 3 zeros and a 3.6. It's now going to be 3 zeros and a 3.5. So it's still getting further away. Which I suppose makes sense, because this velocity is not getting to where it's supposed to be getting to. It's just kind of surprising that the tarsus is like kind of stealing that much from it. The tarsus isn't really getting any closer. This is also not getting any closer. And it's kind of extra weird that its velocity is so far off from what it is trying to be. But it is in sort of a weird state as well. Because this is actually a case where I want the velocity to... Well, maybe not. I don't know. This one has a weird thing going on. Because I know if this is the angle and this is the target angle, I should want a... I guess the error is positive in this case, which means target velocity is positive. But that's not correct. The target velocity should be negative. It should be flipped. Yeah, so far everything just seems like it's reaching the velocity that it wants to go to, but it's not reaching the angle that it wants to go to. It's slowly getting further and further from that. And I think right now it's a little bit safe because all these velocities are kind of relatively small. But it is that everything is just kind of building up to higher and higher velocities. So if the angle is consistently getting worse, then I think that definitely means my velocities are wrong. My targets are wrong. I want to be at 3 zeros and a 1 6. I was at 3 zeros and a 1 5. I'm now going to be at 3 zeros and a 1 6. But did this improve? I want to be at 0. I was at 4 zeros and a 3 4. I am now going to be at 4 zeros and a 3 4. It's not moving. I just want it to be obvious. It's not obvious yet that this is definitely wrong, but it really looks like it's wrong. That I just have the wrong angles. Or the wrong target velocities. Caused by the angle math being a bit wrong. Desired velocity, 2 zeros and a 5, 5. Prior velocity, 3 zeros and a 4. New velocity. Okay. And then the angle. I want to be at 0. I was at 3 zeros and a 3. Okay. It must be getting worse then, right? This one's velocity is not getting there. Yeah, okay, this one I really don't get. It will not reach that value. It will not. It is staying at this distance from it. Desired velocity basically doesn't change. It's sure about that velocity, but that velocity does not do anything. I think it's the wrong way around. I am going to flip it. However, it needs to be flipped. I could flip around target angle and angle. I could just make the result a negative value. Yeah, I think probably the right thing to do is just to get these two inputs to work. So I just know that if I want to decrease, the velocity would be positive, which does just kind of mean I need to flip these two around. I could also just make the target angle be negative. So if I want to increase, so let's say angle is 1, target angle is 2. The delta from there should be 2 minus 1, which is 1. What I actually want then is a negative 1. So a way that I could do that is by essentially negating both, I guess. I guess that's what it would be. Because if I just negate 1, then I end up with a stronger, I end up with something like unstable. So yeah, I think I just say negative on both. Or I could also flip them around. And then note this. So if angle is 1 and target is 2, then I want a -1. Let's hit continue the first time. And then I'll see what's going on. Okay. So hopefully I'll see that I've gotten closer. Whoops. Okay, well, I'm pretty sure the desired and the joint is working correctly. Yeah. I was already pretty sure of that. Though I wanted to see what the actual change was. Okay, so this angle wants to be at pretty much 0. Prior angle was 3.0378. New angle is going to be 3 zeros and a 2, 2. So that's in the right direction. Yeah, because I'd want a positive velocity to reduce the angle. And I'll see what this thinks. So go from that to this, I'd want a positive result. Right? So yeah, then this issue just kind of comes back again where it's going to kind of flip and go the wrong way. Because it should actually still be increasing. Because we didn't get there. Desired velocity, negative O2, current velocity, or previous velocity, positive O2, new velocity. Yeah, okay. So we definitely approach the velocities that I want that I set, so that still works. Do we approach the angles that we want? Positive 3 zeros and a 4-8. Presently positive 3 zeros and a 2-8. Did we get closer? 3 zeros and a 4-2. We got closer. That's good. So then, like I said, the thing now is that it should still be accelerating because we're not there yet. So yeah, because looking at these two values, joint angle, target angle, it should be a negative, right? Current velocity delta is negative, so this value should increase a little bit, get further from 0. And it is getting further from 0. Okay. This one, hopefully this one I see this have like a dramatic change right away. Because last time it was just doing nothing the whole time. Still check velocities. Desired velocity 3 zeros 117. Previous velocity was a little bit below that, or just nothing. And now it looks like exactly the value that I set it to. Good. So now hopefully the angle then says exactly the angle. It's the same thing again. It just doesn't move. What's the mistake here then? Somehow it just doesn't move. Okay. Well, I'm just going to hope that on a subsequent call or iteration, it starts to move it. So I should still be getting a positive. I would want to see a positive value out of this. Okay, it's still positive. Um, it got worse. It got better the first time, and then it got worse the second time. So it's going to be the same thing again. I still want to see a positive acceleration out of this. It's negative. Gonna do there. Oh. Is it supposed to be a velocity change? How do I know? How can I set this up? Because it is as the angles get closer together, I want to make smaller changes, but still in the correct direction. The very first step, well, I mean, I guess this is always sort of telling me an acceleration, isn't it? But then I think there's an issue when it gets into checking the velocities together. Maybe it's more that I say desired motor velocity plus that. Yeah, I still think this might be right then. This velocity might still be right. But I still have to incorporate somehow the real velocity of the thing. Which the real velocity includes the changes I've already made to it. Which isn't necessarily wrong. But then when compared to target velocity, it is wrong. can I do? Because what's happening is that target angle is approaching angle, right? And that's always giving me a velocity. That velocity is sort of it's like on the first iteration. That just is the target velocity. But on the next iteration, the velocity of this is what is causing this target angle to be near angle. So this could be a large value. But then this comes in and says, okay, well, we want a small value now. And so it says, all right, so let's make it a small value. And then this gets further. And this will go up. Like it'll, if there's like the set point and here's the real point, it'll be like this. Like I'm guessing it'll be kind of like this. Like it'll sit beneath it, it'll never quite get there. Or it'll fluctuate like really hard and then slowly approach it. So I mean, I suppose what I can do is I can make this be an accumulator somehow. I set target velocity and I keep adding to it. So I'm always just adding up target velocity. At the start of the next frame. Like say it overshoots. Okay, I don't know. I'm gonna go get food. I'll be back. I'm gonna try to think about it. I'm back. I've got food. I'm going to eat. I thought about it. I think what I will do is I need to accumulate the total velocity, the target velocity. And it would just be reset every start. And I think the way that I should accumulate that is actually just say target velocity will be adding to desired velocity. I think I do just accumulate it, and then I reset it. Because if I just add it to desired velocity, then essentially that means on the next frame that I start, the first result that I read in is going to be like, okay, this should be the full target velocity. This is what it should be. So like say I go over, and it now becomes the case that my target angle is just above my real angle. Sorry, my actual angle is just above my target angle. So I want to come back. Now this isn't exactly the same way because it's actually inverted in the numbers, but let's call that a negative rotation. It's going to be a small negative rotation. But the current desired velocity is going to be like 2 or something. So like, hey, we overshot, but we want to decrease that just a little bit. Or maybe not actually, because I do actually go back in there and I start over from the... I initially apply a full step of that. Of what I had last time. So I start with the assumption that I'm going to continue, or that I'm continuing from the prior frame. So my estimation starts with my current velocity, my actual desired velocity, adds all that. So in that case, actually no, so this is right, yeah. If I were to overshoot slightly, then I say, all right, so let's decrease that desired velocity by a little bit. Okay. So let's call this that velocity delta. And then I'll say target velocity float would be still limited like that. And then I would calculate target velocity is good and set. I have to just recalculate the velocity delta. Which would just be that. I can't remember exactly how that math works. Lambda is new minus previous. New minus previous, yep. Yeah, and then if I were just look at this and think about the math, then this is the equation. I'd move this to the other side. So it'd be target minus desired to get the new velocity delta. I will be right back to step through that. I'm back. Yeah, a little bit lower. Okay. So hopefully these approach with some speed the desired results. I don't think I really need to check these ones. I'm sure those are always working every time. So yeah, for now, I'll just let this be the only thing that I look at. So this is the first run, and then I think I probably... Let me double check something. Yeah. I do specifically reuse the last torque, which includes that desired motor velocity. So it is technically included. Okay. Technically, literally, it is literally included. All right, what have I got? So initial run is doing nothing but setting up, really. Negative 007. The angle. Zero, zero, 0, 378. And this one wants to be at, I think, 0. Essentially 0. Sorry. Oh, compile days. I didn't update that. Did I? I don't think I did. No, I did task. I did not do this one. Okay. I can probably just skip through the first run. I'll check this. I will check this. So I read this as a velocity delta. So I'm at here and I want to go to here. So it's a decrease in the angle, which is a positive rotation. So I accumulate that delta. And then this should all be the same thing. It's like positive 0, 1 almost. And not quite, but yeah. Okay, that looks correct. Jump. Jump. Okay. So joint velocity should be approaching the desired velocity. It's like a total flip of the sign. And we actually overshot it. So we overshot it, and then hopefully the angle gets close. So the prior angle was 3 zeros and a 378. We want to be at 0. It is now 3 zeros and a 2, 2. That's good. And I need to make sure that this accumulator works correctly. So our target angle, here's our angle. So we still want to be decreasing. And this is an accumulated delta. So essentially, what I applied was like a third of the way there. So in theory, if this was like really estimating it, then I would kind of at this point double that. First velocity delta is 0, 0, 1. 0, 0, 6, 4, really? Wow. Okay, so it doesn't really accumulate very fast. Because yeah, I feel like that should be a lot higher then. Okay, so the target velocity still increased, but then the actual velocity overshot that. Which, yeah, in this case is interesting because if that was the real velocity and that was the angle change, then you can kind of predict what the real velocity should be. What is this? Why are you sending random links? Dude, what is that? That's a big PNG. Okay. Dude. Don't send that. Don't send random websites. No, I'm not showing that site. I don't know what that is. That's a very suspicious website. Acceleration is negative. Hopefully it's a very small change, right? 3 zeros and an 8. Yeah, okay, it's a small change. It's funny. I don't know. No, it's not. I'm not laughing. I'm annoyed you sent a site like that. I'm anti-fun. Sure. Call me anti-fun then. If that makes me anti-fun, then I'm anti-fun. Okay, so the delta was still a slight drop. But hopefully what comes back after this is that it needs to increase again, because the angle is going to decrease and now the velocity is lower. Or it might overshoot it again. Or because the Tarsus is doing something, then it's like getting help. Or wait, what part is this? Or because the tibia is doing something, it's getting help from that, so it actually does need to slow down or something. Or it needs to be a little bit lower. Yeah, ideally, I think at least tibia should be pretty good. Prior joint velocity was 0.27. The desired is negative at 0.2. Current velocity is reading 0.127. So it's approached it. Has the angle approached? It wants to be at 3 zeros and a 4.8. It was at 3 zeros and a 2.8. It is now at 3 zeros and a 4.2. Okay, so that still looks the same. But now the key difference here is that this is going to continue to accelerate. That's a big thing. So this is our measure. This is where we want to be. So it should still be like a negative, right? It needs to accelerate a little bit more than this. So it'll be a negative. Last value was also negative. We're going to accumulate that so that our target velocity is negative. A little bit. It's very slight. But it'll stay there. We will maintain that acceleration. I angle 0. desired. So we reach our desired. But then I'm just going to assume that the angle didn't change because this angle never changes. Somehow this angle just struggles to change. 4 zeros, 3, 4. 4 zeros, 3, 4. Yeah. However, due to sorry, due to this accumulation of it, it's actually just going to output the same value as it was last time, so it's actually just going to double it. And it seems like it might have gotten worse. 117, 164, so yeah, it's actually going to increase it by quite a bit. Though the strange thing is that the velocity works, but then the angle doesn't change. Is it because the way that I apply the... Well, no, I just apply rotation constraints. I don't apply position constraints. So every time it runs, it's still going to... Like, this is going to rotate, and then we're going to equalize a little bit. Right. I have something cool booted up. You just want me to spend 10 seconds breaking my focus. Doom playable in YouTube. Is it just the same thing where you have to rotate? I mean, cool, but it's like an honesty game. I'm not a lens. Stop focusing on shit. I think that is a little bit incorrect. Cameras focus on things. They move lenses. So you're right that I'm not a lens, but that doesn't mean that's not what... I'm the camera. Okay. Was the last part right? Yeah, the fever. Okay. Take that off. Continue. Okay. So desired is that. That's our present value. This is our angle. We want to be at 0. So I just assume the desired motor velocity should match pretty well. Okay. It's gotten worse. It's gotten worse. So velocity is still trending away from the desired. And I would bet that's just because the tibia is doing work on its own at the same time. How's the angle? Has the angle improved? I'm not sure if the angle should improve here. We want to get closer to 0. It was 3 zeros and a 2. It's improved. Okay. The angle has improved. Tibia, that game looked so weird. I still don't know what that is. Maybe I don't want to know. All right, so I'm still a good distance away, so I still want to continue. What would I be doing? That's my measure. This is my target. So I want to decrease, which means I want to increase the rotation. So velocity should still be positive. 00115. Okay. It is moving slower. It increased a little bit. I mean, yeah, because if the angle isn't changing, not really, then I want to keep applying that large change to it, the large change to the velocity. But yet at the same time, the velocity is kind of taken off. Look it up? No, I don't really want to. Joint velocity, desired velocity, new velocity. It kind of didn't really change. Which is weird. It's like neither one of these are really getting to the velocity that they want to get to. The angle, this angle is actually super close, so it's pretty good. What's the new angle now? 436. It's just getting closer. Good. And it's not really shooting over it. So present delta is that, so I would expect to see this decrease very, very small. A very, very small decrease. Ooh, okay. It's gonna double it. Why? Why would you double it? Well, I guess it's because the velocity... I mean, I guess I'll see, right? Like, I think the expectation is that it probably will overshoot it and then come back, but it's not going to be that dumb overshoot where it overshoots and then like hangs and then takes a long time to return. It should go like overshoot and then maybe a little bit of an undershoot and then, right? So now the femur. Start velocity. This. New velocity. Pretty much the same thing. As angle improved. Four zeros and a 3-4. Angle just doesn't change. That's weird. I don't get it. Why? How is angle? It doesn't look like it's getting worse, but it's just not changing at all. And I'm certain that it's still rotating it. And the majority of that rotation goes to the part itself. But somehow that doesn't count as... Why does this one not change angle? The ones are rotating. This one doesn't. I do know that it is a small piece between two large pieces. The thing is, when it rotates itself really well. It's at the velocity that I set it to. And yet, when I do the rotation, it's like it doesn't do anything. Check this. Down. Stop asking me to do things, please. I'm checking. Stop asking me to do things. I checked. Please filter yourself. What Alex Jones warned people about. I don't even know what that is. You've demanded my attention 3 times now, and every time I don't care. I'm anti-fun. I'm working. If you show me something cool, or you show me something related to games, fine. But you're sending me just random stuff. Like, if it's a link, I have to check. I have to check. I can't just leave a link sitting there and not know what it is. I can't imagine why. I'm not getting any idea. And now I'm second guessing the whole thing because technically I'm accumulating it, but and I even reach it. Yeah, just why doesn't it change? Why would it not rotate? This has a very large velocity. Oh, this is a different one, isn't it? No, this is the same one. This velocity is like 10 times what it needs to be. Well, okay. Okay. I suppose... Okay. No, because even then, this should be like 3-1 at this point. Because like, all right, well, velocity is technically divide that by 100, and that's going to be the real angle change. But I'm at like 4 now, which means the next time this runs through, I should I should see like a 3-3 or a 3-2. Really, I should see a 3-0. That's what I should see. But I'm not seeing that. So it's really strange. Alex James is such a fantastic guy. I love him. Wow. I don't think so. As he's said himself, I believe that he was not a good person. Next run through. Don't need to see any of that. Maybe I should check that to see if there's something weird going on. These other angles are changing. The velocities are changing. Just the femur's not. As far as every day to listen to his 2003 tapes, you'll start understanding more about the real world. 2003? I didn't even know he started that early. I'd be 5 years old or something at that time. Desired velocity, actual velocity, did we approach? It's getting further. Interesting. Okay, so joint velocity still gets further away from the desired. But does this angle approach what we want? I want to be at 0. It was 3 zeros and a 2 1. It is now 3 zeros and a 2 0. So it's so slow to get there. That is really slow to get there. We wanted to be at this big negative value. I mean, the one that really matters here is that the joint angle gets to IK angle, and then it should stay near that. That's the really important part. When we have 487, it was at 437. It is now 448. So this one's getting the angle it wants to be at pretty quick. I just wish the other ones would also do that. Because the other ones seem to be like... The tarsus now is barely moving. The femur has just not moved at all this whole time. It continues to use a higher and higher velocity. And it continues to just do nothing. But it's getting the velocity it wants to be at every time. I know that it was 3, 4, and a 0, and probably a 1. Now it's a 3, 4, and 2 zeros. Great. Silly, silly, silly. Hopefully, when it steps through and it comes back, the joint angles are... They don't flip. So this one wanted to be at 0. So hopefully that means it doesn't flip to be a negative, because then my prediction was wrong. Somehow. And the ones that were like, oh yeah, we're spot on, don't come in and say, oh, we're really, really far away now. And also that my predicted joint velocity matches as well. So this was femur. So I'm going to continue. Okay. Why does that keep opening? Oh, never mind. That was correct. I'm just going to quickly check this one and then... I guess I'm going to check them all. It got worse. Okay. Do I have to translate them too? Whenever I do this, do I have to... The way that the motors work is they actually only apply torques. Which, if your motor is like the center of a wheel, that's fine. But I'm not at the center of a shape. I wonder if what I should do is read in the velocity, just like very plainly read in the velocity, and then say, okay, cool, that's the angular velocity. All right, I'm going to make a linear impulse now. So I go to the center, I increase the rotational velocity, because pretty sure exactly what happens here is it uses that rotational velocity, and then it uses, it uses positional constraints to make them match up. Maybe what I should actually do is add a linear velocity at the same time. Because I think that this does not apply linear velocities. This just does angular. But if I were to apply that linear impulse, would that help? The way I see it is that kind of imitates like a very rigid motor. Or like very rigid parts. Because instead of like a motor being like, oh, I'm gonna push here and then push here, it's like, I'm going to push here, but I'm also going to lift up on the other side at the same time. The what bought the World Cup? Who? I need to remember that idea. Because I wonder if just doing that kind of takes all of this away. If it could take all this away. I'm just thinking of like a tent with a motor at the middle and applying some rotation. That would like it would move both walls. It would rotate both. But the only thing it does is it changes their angular velocities. Because yeah, then it basically does this. And then it says, okay, let's fix that. And then it moves them apart like this. It doesn't... I would think what would happen is it would do this and then fall, right? But what would really happen is it'd probably just do this. And like fall down faster than you would think it should. But is that applying too much force? That should apply too much force. Because I'd be rotating and moving at the same time. Yeah, wow. Wait, this is like a max acceleration right now. And apparently is doing nothing. Yeah, it's at the maximum acceleration. Is it the last one? Yep. Step forward a frame. Yeah, this one's very important that I check. Very, very important that I check. Because my incoming joint velocity should match what the actual velocity was. Very closely. There's not a match. I would say the not match is not really too far off, though. It is worse, though, than the desired. It's like almost 3 times the desired. And it is just the opposite sign. And almost double my estimated joint velocity last time. How's the joint angle, though? That one matters more, I think. Matching. I estimated that I would have a joint angle of 3 zeros and a 215. It is actually 3 zeros and an 8. I mean, I guess one part of my simulation is I don't account for gravity, which just means that I'm not accounting for translational changes. I am strictly counting rotation, which gravity will not affect rotation. But I suppose it technically would, because both parts would fall, and then they would, you know, go back up. Okay. But that's the tarsus, I guess. About the tibia. I expected I would have a result of probably 0, 1, and the real result is 1.1. Though I did have a large negative desired velocity, and it has come back as a very positive value. So is there a possible sign that it's inverting? That it is inverting? Not sure. The torques are still low, so it might just be that the torques are really kind of unable to do anything. I predicted I would result with an angle of 3 zeros and a 4-4. I was completely wrong about that. The other sign of that. Which I suppose makes sense because the joint velocity is really high. and I wanted it to be the opposite sign. And the result is that the angle that has come out is very much opposite of that. Okay, what about femur? I predicted a joint velocity of 3 zeros and a 4. I got 3 zeros and a 5. Okay, that one's really nice. That one's close. I predicted my angle would just not change at all. It should be 0, 0, 4 zeros and a 3. Right? And I'm going to get 4 zeros and a 5. Sure. I'll accept that. That was kind of the expectation. Either it would not change or it would go backwards. And it went backwards. Okay. And now undo simulated predictions. I ended up with a desired velocity of 0, 0, 5, and I got 0, 2. Okay. The angle I want to be at essentially 0, and I got an improvement, I guess. It was 3 zeros and an 8, 8, and now it is 3 zeros and a 4, 4. I want an angle of 0, 0, 1, 5. Or I guess I'm looking at velocity first. Yeah, I just want the exact opposite velocity. Okay, we got a quarter of the way there. Supposedly. I want to be at 0, 0, 1, 5, 8. I was at a negative angle, and now I'm at closer to 0. Okay, we've approached. Though barely, I would say. Got a lot longer to go. Whoops, didn't really check that. Well, it's pretty close. This one's always been close, but the angle just never changes. I still want to just be at 0. Barely changed. Is it possible that I have the wrong angle? Because it seems like all the angles got worse. This is 3. This is 4. This is 5. Now you're just making me ignore you. I want to be at a very negative velocity, and I approach slowly. I want to be at an angle of 0. And I get further. Do I have the wrong idea? I wouldn't ignore you if I was me. I think he might have said that wrong. I think you might have said that wrong. Well, I mean, if I have it backwards, then I have it backwards. Again. Desire, wow, yeah, desire is just still highly negative. And it's still increasing. I want joint angle to be positive. It was negative just now. 000231. It has gotten worse. Okay. This one continues to approach. And how is the rotation? 4 zeros and a 5-2. 4 zeros and a 5-1-7. So those could be the same number. Could be worse. Could be better. I don't know. Step forward one more time. And now I see again. If this is a trend, then I'm incorrect or what? I desired to be at 044. I estimated that I would be at 007. I have substantially overshot my target. Okay. By 3 times, almost 3 times. And I just clicked right over that by accident, so okay. I expected 0.8. I wanted to be -2.5. I ended up with +2.5. +2.5. Okay. Don't click over this time. I expected to be 3 zeros and a 3. 2 zeros and a 3. I mean, what are the chances of these numbers like this? I have a -2.5, I end up with +2.5. I had an IK target of 0032, I ended up with -0029. These are actually kind of close. I wish I saw the other one. Oy. Well, I guess that one actually does make sense because I want it to be a 0, right? So 0 would just be to undo the current angle. I predicted 00125. I want it to be 0014. I end up with 00139. Okay. And hopefully the angle improves. I want to be at basically 0. I was at 4 zeros and a 5.2. I am now at, or I expect to be at 4 zeros and a 5.2. I'm now at 4 zeros and a 6.2. So this prediction is still pretty good. The other two are kind of insane how wrong they are. Well, I didn't see how wrong the first one was because I skipped over the angle. Alright, let me just hit continue until I get to the next frame. Okay, I expected I might be at 0012. I wanted to be at -05. I end up like 3 times. But still in the right direction. So then hopefully joint angle has improved. I wanted to be at -3 zeros and a 147. I expected I might be at 2 zeros and a 1.3. I am now at 2 zeros and a 3.8. It's just getting worse. Though okay. I think I've got the wrong idea. Seems like I have the wrong idea. If I want a negative angle, I need a positive joint velocity. I'm pretty sure my joint velocity, yeah, my desired velocity is negative as well. That doesn't really make any sense. So seeing this angle, I should start calculating, I believe, a positive velocity. Gunpowder was like AI tonight. Joint angle, K angle. So if I want a negative angle, I need a positive rotation. Positive 0.2. Okay. Correct responses. I expected to be at 135. I wanted to be at negative 3.7. What did I end up with? 3.6. This one is just getting really bad. Strangely. Want to be at positive 0.5. I expect that I would be at negative 0.001, and I'm actually at negative 0.005. This tibia is so strange. I don't know. I think this one is still just the same way, where that is the angle and the IK angle is just to completely undo that one. So I guess that counts for that. But then the velocity just coming in opposite like this is very weird. I guess the technicality is that it's applying most of its. It's technically applying most of the motor's applying most of the rotational velocity to that femur, but the femur just kind of kicks it out completely. It passes that up to the main body, and at the same time, that joint isn't allowed to rotate on that way, so it kind of cancels out any velocity there as well. So I'm guessing what's sort of going on is that it's kind of just not moving the tibia at all, because almost all of the force is going into the light femur and then disappearing, basically. So I kind of wonder if I should just do like a linear impulse. Figure out how to apply it in a way that maintains the correct torque. Or maybe I just say ignore the torque and just run it. Let it be a stronger motor or something. I expected 002. I wanted 0025. I got 0024. I mean, this one's still just being so close, I think. Though it is still the case that this one's angle is just not moving at all. It just does not care. I thought it would be at 4 zeros and a 6-1. I want to be at nothing, and I am now at 4 zeros and a 7-2. It's just getting worse still. We do this. Let me take this line out. And just step through it. And see what it tries to do. I don't know. I don't know what it means. I don't know what it means. It is it's hard to tell what's really going on here. Let's see if I flip this around. How does it look the exact same way? How does that actually look no different? I think it does look like the same thing. That's crazy. What does that mean? That it looks the same? What does that mean? How could it look the same? It looks the same. How? How? I don't get it. Did I like not hit save maybe? Save it 20 times. Hello, Ronan. Is the idea what I'm seeing on screen up, but something tells me it's way out of my neurological capabilities. It's out of mine too. Because this doesn't make any sense to me. What I'm seeing. Okay. There's some kind of 3D spider animation. More like a physical model. Also, it's got 6 legs, so I call it a crawler. And it's just that it has some weird responses. Like the exact same thing happens no matter what I set that to. That's crazy. Exactly the same thing happens. And it's really, really bad. It's really bad. So it's about trial and error. Yeah. Though it sucks that I don't. It does the same thing. How is it the same thing no matter what? What's really wrong with the output? Nothing is wrong with my output that I can tell. It just seems like whatever I do, it does the same thing. So if it's like, I want to rotate 1 degree, so let's set my velocity to 1 degree per second, it's like it comes back saying, okay, yeah, we're at -2 degrees per second now, and our angle is now -2 degrees. So I'm like, okay, so if it's 1 degree, let's go at -1 degree per second. It says, oh, okay, we're at -2 degrees, and we're at -1 degree per second. So I don't, that's what's happening right now. And it's really odd. They're definitely moving way faster than they're supposed to. Like, I don't know. It's super weird. Okay. What? How low does it need to be? It was finally done something a little bit different. Just get rid of that. So it's backwards right now. Why? Why? No, really, why? Why? Why does it not matter which way I put that? It just does. That's insane. It just does the same thing. Oh. I think that's probably it for today. I am perplexed. That is the weirdest response. I literally invert its response to angle changes and it does exactly the same thing. I mean, I suppose all it means is that, you know what? Let me try that. I could figure it out. by making it one iteration and see which way is the right way. Because I guess because it does iterations, even if it's backwards, it bounces around the target, right? Somehow. I mean, I don't know. I don't know how it would do that. Maybe it doesn't do that at all. I don't get it. It's so weird. It's like correct though. This looks correct. In a weird way, that looks correct. So now I'm gonna flip. This should be inverting how it responds to angles. And it kind of looked like it did the same thing. So I don't know. I don't understand. I am done with the spider thing. I'm not making a spider. Yeah, okay. I think I'm just done for today. I need to make like a graph thing so I can see the outputs. I can see it changing in real time. I can see how no matter what I do, the angles get further apart from the targets. But I mean, the thing is, like, the legs they're still rigid. They still end up rigid, like, whichever way I put it. Like, they stay rigid, and then just some of them, like, lift up, and then... How did I make it so that only one leg was moving? I don't know. I don't know how I would just toggle them. Yeah, I don't remember how. It's too weird. It's too weird. Maybe I will try that idea that I had, where I also apply a linear velocity to everything and see if that can really assist with it. Because then in that case, I can just say, all right, what's the angle? Okay, there's the angle. So let's apply. I mean, I guess I could also just go really simple here too. I could just try a really simple result where I say the acceleration is just going to be the difference between a very plain calculation and the current desired velocity. I'll just try that. Who knows? I can't tell. I can't tell. All right. Maybe that seems wrong. Positive point two. Thanks for following Aleph 33. Honestly, I don't know. They both suck. So, yeah. I gotta stop there. It's not making any sense to me why this is still just super wild like this. Okay, so that's wrong. That's wrong, right? Is that wrong? I gotta stop. I don't know. I really don't know. Because now this one has decided to overextend. And this one at the back just can never stop because it's just cycling forever. Maybe I should just find a better way to move the legs entirely. Because everything I'm doing here with the motors just sucks. I can technically pick target orientations. A target orientation is pretty much impossible for me to do wrong. I don't have to do anything on this side. I just let it do an iteration, say, is that what we want to be at? Yes or no. Here's the change for that. I would like to be able to do it this way, because this way has a bit more tuning, I guess. But I mean, maybe it just doesn't even matter. Like maybe I'm just at the point where I say, all right, everything I've done here sucks, has not worked yet. I've like written it 4 or 5 different ways. That's the same thing. It either doesn't move, or it moves way too fast, or it just seems like it's doing something random. Sorry. Thanks for watching. I'll be back tomorrow. Goodbye.